Hello, my name is Jacob Goldenstein. I'm doing the video assignment 1 work. So here's my paper. This is what I will be showing you guys. So for problem 1, we have to figure out what it is. So it's rational. We have to use the quotient rule. Let's see. Quotient rule, and we have to rewrite the function. So rewriting it would rewrite. This would come along the lines of 4x to the power of 3 over x squared minus 2x over x squared minus 1 over x squared. So this is rewriting it for the start, for rewriting this problem. Then we have to simplify it. So this can simplify to f of x equals 4x minus 2x squared minus x to the power of negative 2. So now since we rewrite it, we can do the next step, which is using the power rule after the quotient rule. So step 2, use power rule. So now we have to use the power rule, and that comes with the function of f of x equals a n x, or no, axn squared. And we have to find the derivative. So finding the derivative, we'd have to use f of x equals anx to the power of n minus 1. So this is what I have so far. I use the power rule, and this is what the power rule is. And find the derivative of it, you have to swap it around and make it to the power of n, and plug in n as a term. So now, since you have n as a term, you're gonna have 3 terms, and you're gonna first start with 4x. So your terms are gonna be 4x, negative 2x squared, and negative x to the power of negative 2. So your first term, which is 4x, you have to find the derivative of 4x. So you're going to do d over dx bracket 4x, which equals 4, because we're using x, and we're using that function of finding the derivative of the power rule, which is anx to the power of n minus 1. So we're using that function. So we're going to do 4, plug in 1 for n, x is just staying as x, and n is going to be 1. So that's to the power of 0, which is going to equal 4 again. So the derivative of that is just going to stay 4. Now for the next term, second term, it's going to be negative 2x squared. So d over dx, negative 2x squared. We're going to do negative 2 on the outside of the bracket, negative 2 negative 2, and then negative 1 on the inside. X to the negative 2, which equals 2x to the negative 2. So instead of it being negative 2x squared, the derivative is now going to be 2x to the power of negative 2. And the reason for that is because when you plug it in, the negative 2 and the negative 1 cancel out to move the negative up to the exponent. So now the derivative would be 2x to the power of negative 2. And now for the last one, third term, we're doing negative x to the power of negative 2. So d over d of x, bracket, negative x, negative 2, equals nothing in front because there's no value in front. Oh, I forgot the name of it. So it's going to be negative in front because that's the value. So negative x, 2x, 2 close parentheses x to the power of negative 3, which equals 2x to the power of negative 3. And the reason for that being is you would FOIL in the negative to the negative 2, which would make it positive 2, x to the power of negative 3. So here in this bottom squared area, you could see me trying to find the terms and doing the math for each one. So we have our 3 terms, and our 3 terms are, let's see, I need to flip this. Our 3 terms are, what are our 3 terms? 4, three terms are 4. So, yes, so 4, 2x to the power of negative 2, and 2x to the power of negative 3. So our final answer is going to be f of x, so the function of 4 plus 2x to the power of negative 2 plus 2x to the power of negative 3. And that is going to be your answer to question 1. It's just going to be f of x equals 4 plus 2x to the power of negative 2 plus 2x to the power of negative 3. And as you can see here, my final answer is boxed. So let's get a new paper to start with problem 2. Let's get rid of that one. So now problem 2 is going to be f of x equals x cubed plus 3x plus 4 over 5x cubed. Always make sure you write your function and question the problem before you do anything. So as we can tell, the function can't be written easily because there's no corresponding numbers to a 4 because there's no extra number. There's not the same amount of numbers as last problem and the above and below, because in the first problem we were using 3 components on the top and only 1 on the bottom, 1 denominator, but this one we have 3 on the top and 2 on the bottom, so we have to do more work. So once again, we're going to use the quotient rule, and this quotient rule is going to be g x over hx, and then the little this is going to be your quotient rule, and it's stating that equals g x h parentheses x minus g of x parentheses close h x. So now, since we have this here, it's going to be all of that over h bracket h parenthesis x squared bracket squared. So get rid of the bracket inside, sorry. Squared outside the bracket. So now rewriting this, it's going to look like this. And the reason we're doing this is because there's two terms on the bottom. If there's only one term on the bottom, we would do what we did last problem. So this one's going to have a little bit more steps. So the numerator, which is g of x, is going to equal g of x cubed plus 3x plus 4 all over 5x cubed plus 4x. So g of x is going to equal the numerator, which is x cubed plus 3x plus 4. And h of x is going to equal 5x cubed plus 4x, which is the denominator. So the reason we need to know the difference is because we're going to have to use both. We're going to have to use both when we are solving. So we need to make sure to separate the denominator and numerator because we're going to have to find the derivative of both. So first we're going to do the numerator, which is g of x. So g x equals d over dx, which is going to be equal which is going to be not equal. It's going to be bracket. Let's see what we do here. Yeah, it's going to be bracket x cubed plus 3x plus 4, and then close the bracket. So that's a start. Now we're going to have to use the power rule because there's a cubed. So once again, d over d of x cubed equals 3x squared. Oh, okay. So for the 3x and the numerator, add the square. I forgot to add that, but I just caught myself by relooking. So for x cubed, the derivative is 3x squared. For the next one, which is 3x squared, not x cubed, this one is going to be 6x. Now for the derivative of the last one, which is 4, it's going to be 0. Using the power rule. This is all using the power rule. So to end that off, since we have our three terms, it's going to be g of x equals 3x squared plus 6x. And why do we not have a third term is because it's 0, so we're adding nothing. So this is going to be our g of x after using the power rule and find the derivative. So if you see it there, right here, this is going to be our answer. So now we have to differentiate the denominator, which is h of x. So h of x equals 5x cubed plus 4x. And now we do d over d of x bracket 5x cubed plus 4x. Now we're going to try to find it to both. So we're going to do d of x so d over d of x bracket for 5x cubed, which is going to be 15. Yes, it's going to be 15, which is then going to be 15 squared. And then d over d of x, 4x, is going to equal just 4 because you just get rid of the x. So now we add those together. There's no more terms because there's only 2. It's going to be h of x equals 15x squared plus 4. So now we have our denominator and numerator with actual values instead of just non-values. So we're going to do the quotient rule now. So here's a step 1, step 2, and here's step 3. So in step 3, I gotta pick that up with my paper. So step 3, we have to find the quotient rule. So it's gonna be a bunch of terms combined. So it's gonna be f of x, because that's our base, equals f of x equals 3x squared plus 6x, 5x cubed plus 4x minus parentheses x cubed plus x cubed plus 3x squared plus 4. I need to go down a line. And then we do 15x squared plus 4. So why am I doing this is because the first two terms are going to be from the base of, the first term, which is 3x squared plus 6x, is going to be the answer to g of x after using the power rule. The 5x cubed plus 4x is going to be the base before we used h of x. And then the third term, which is what we're subtracting, is going to be the base of g of x. And then the last term is going to be after using the power rule and h of x. So it goes answer to g, start of h, answer to h, or answer to g, start of h. It's kind of confusing, in my opinion, but that's the way you have to do it due to simplifying it. Here, I'll write it down. It goes gx. This is just hx. Normal gx. And then hx. As you can see here, I put little things above them so you can tell the difference. And that does matter a lot, and you might be wondering why. And that's just how you solve using the quotient rule, because like we stated earlier, it's going to be g of x over h of x, parentheses, and then the answer after the power rule. So now we have to expand this, which is going to be, let's see, expanding. So we're going to go, first we're going to do 3x squared plus 6x. So the first term's in the second term. And that expanded, you're going to FOIL it, 15x to the power of 5 plus 30x to the power of 4 plus 12x to the power of 3 plus 24x to the power of 2. So you kind of just simply FOIL it. I can show you my ways of foiling. That's kind of what it looks like. Kind of just move it over. Anytime it's just a base x, you add that to your exponent. So let's say 6x times 5x cubed is going to be 30x squared, because you're adding that x from the 6, not just the normal exponent. So you're going to add an extra one. Now for the second part, we're going to do x cubed plus 3x squared plus 4. 15x squared plus 4. So expanding this, we're going to do 3 terms of 2. So you're going to do all 3 to the first term and all 3 to the second term. And doing so, we're going to get 15x to the power of 5 plus 45x to the power of 4 plus 4x to the power of 3 plus 72x to the power of 2 plus 16. And here's our second way of foiling. Just goes like that. But now we have to subtract the 2. So now we're going to make them make them into parentheses to make them their own term. So 15x to the power of 5. This is all in one parenthesis, plus 30x to the power of 4, plus 12x to the power of 3, plus 24x to the power of 2, subtracted by 15x to the power of 5, 4x to the power of 45x to the power of 4, 4x to the power of 3, 72x to the power of 2, and 16. So now we are going to subtract these. As you can tell here, we want to subtract these terms so that we can cancel the terms and simplify it. So we're going to get negative 15x. And this is combining your like terms. So I'm going to get negative 15x to the power of 4. So there's no more power of 5 because 15x to the power of 5 minus 15x to the power of 5 cancels out. So now we're moving over to 30x plus 30x plus 45x to the power of 4. But remember, there's a subtraction sign in the middle. So we're going to FOIL it over to the 45x to the power of 4. We're going to make that negative 45x to the power of 4. So 30 minus 45x to the power of 4 is negative 15x to the power of 4. Now we're going to do the 12x, move the subtraction sign to the 4x to the power of 3. 12 minus 4x is still going to be 8x to the power of 3. And same thing with the 24x. We're going to do 24x, but minus 72x. So 72 minus 24 is going to be minus 48x to the power of 2. And then we don't have any normal x term, so we're just going to move over to the 16. Move the subtraction sign over, is going to be negative 16. So we have our numerator now. Let me show you our numerator. Our numerator is going to be this. Now we have to put something over for the final derivative to finish this problem. So we're going to rewrite that negative 15x4 plus 8x cubed minus 48x squared minus 16. Now we're just going to put that all over our original value, which is going to be 5x cubed plus 4x to the power of 2. And now, as you see, this is going to be our final derivative. So that is our that's my thing to both problems. Thank you.